Everybody, welcome back. So in this video, we're going to talk about the first part of our little router challenge design thingy that we're doing on the channel. So if you didn't see the last video, the idea was that I set forth the idea of a challenge project for anybody who is relatively new to IT or Linux or system engineering, site reliability engineering, any of that kind of stuff, and would like to take something on in a manner that would be representative of how you would do it in a work environment in a professional setting. Now, a couple pieces. First thing is this is going to be interactive, hopefully. So if you decide that you want to take part in this, it would be great if you could post your results, your comments, your feedback, the way that you're doing this in the video comments below. That way, anybody else who is participating in this can, chat with you and we can have a conversation about this. So, secondly is I'm not going to be giving you a design for how to go do this. I'm going to show you how I do it. And this is not by any means necessarily the quote unquote right way to do it. In addition, I think what I'm going to do is I'm going to intentionally design specific pieces poorly or leave things out. And the thought process is I'm not going to tell you what those are. So you have to critically analyze every single step of this so that you put it together in a way that's going to be useful and the correct setup for you, right? Because we're going to have different environments. So the first thing that we want to go ahead and do is we want to go figure out what our requirements are. Because in real life, what's going to happen is somebody's going to come to you and they're going to say, hey, I need you to do this project. And this is going to be blah. In my case, it's we need to go set up a router so that we can share the internet on Nick's boat when we have multiple people there. Right. So that's the requirement that I'm starting off with. So the first thing that we want to go do is we want to go document what the business requirement is. I'm assuming that this is a business and you're going to be relating to that. Could be an organization, could be a nonprofit, whatever it is. In this case is going to be me personally for my little project. For you, it's probably going to be the same thing. Just, tailor it to your specific needs. So first thing that we want to go do is we want to document what is the business need or want that we are trying to solve. In this case, it's very simple. It's going to be people are going to my boat. We need to share the internet. Preferably in a way that's going to reduce the amount of bandwidth being used and accelerate performance. And so, write those down as bullet points. But again, you probably don't have a boat. Make this what makes sense for you. It could be set up a Linux router so we can go share the internet at home, right? So that's your business requirements, right? So the next thing we need to go do is we need to go map that to technical requirements. So what are the technical things that we are going to need to do? Like, what does that business goal actually mean when we translate that into technologies, right? So it's going to be a router. So what is a router, right? A router is a device that has connectivity to one or more upstream internet connections or networks, right? So we don't actually need to be, could be a router between two private networks, but in this case, it's going to be to an upstream. And it is going to provide a default gateway. So it is going to have an IP address that's going to be in another internal network, and it's then going to be allowed those hosts on that internal network to connect to the internet through our router, right? So we need to have a device that has connections to an upstream network and to our local network, right? We need to provide a default gateway, right? Now, in my case, it's going to be just a sort of standalone network. I don't have servers on my boat, right? So there's no DHCP server aside from this. So we need to be able to give clients IP addresses. On my scenario, it needs to be wirelessly, right? Because you're not plugging in a whole bunch of Ethernet on a boat. Might be some things, but get the idea. We additionally are going to need a requirement of DNS. So we're going to either provide pass-through to upstream DNS from whatever provider that we're using, or we're going to go do DNS locally. Right? So we need to go enumerate all of these different things. In my case, I would also like to have a proxy. So now, one of the things to do is to go back and look at those business requirements that we had before. Now, the business requirements is we need to have connectivity that we can share out. And then as an add-on, it would be nice to be able to go ahead and have something that, decreased bandwidth utilization and increased performance. So that means a proxy is not actually a requirement. It's a nice to have, right? So one of the big things that we want to determine is what is our sort of minimum viable product, right? Because that's what we're on the hook to deliver, right? So we want to go ahead and have, our business requirements. Right, we're going to have our technical. And then we all go basically take that and determine what our minimum viable product is. So this is the first piece that we're going to start off with. And then we're going to go ahead and do is we're going to, look at the other things on top of that, right? So what are the additional nice to haves, right? So in our case, it's going to be a proxy, right? So that's where we're starting. So what we're going to do is we're going to go through a process where we formalize this, right? So we want to go make sure that everybody is very clear about what the ask is. What are we being asked to do specifically, right? Because a router is a very general thing. Now, it's very specific in terms of what it does, but there's a whole range of types of routers. There's routers that can, do multiple gigabit upstreams, right? We can do in 10 gig connections to, a dedicated network, right? We could be doing this offsite. We could be doing this over multiple upstreams. So we got to go figure out what the requirements are. So when we're looking at requirements, a term that you'll hear quite often is something called an SLA. It's a service level agreement. And SLAs are something that people talk about all the time, but we don't actually really use in real life. Now, I've been on the hook for SLAs at things like ISPs and service providers, but most people aren't. Unless you're running some kind of service, then you will have a service level agreement potentially with your clients. And that's literally a contract. It's something that says your ISP can only be down, 99.97% of the time or whatever it is. So there's a legal contract. So people will use this term very often, but it's technically not what you actually want to be looking at. What you want to be looking at is your service level objectives. So you want to define these. So these are going to be something that we want to define as basically our requirements. So what is a router to us? So in this case, it's going to be pretty basic for me, right? It needs to go take whatever cell connectivity, cell networking that we have, and provide that to the clients, right? So our first objective is clients on Wi-Fi should access internet. Pretty simple. And each one of these is going to be translated to something called a service level indicator. So like, how do we test that basically, right? What is an indicator that shows if we're meeting that objective or not, right? So it could just be ping, right? If we can ping outside the internet, we're good. And then what we're going to go do is we're going to, sort of maybe break this down a little bit further. Now, there's more stuff that we can get into along these lines. There's the idea of black box testing, which is like you don't know anything about the service that you're using, versus white box testing, where you do know what it is and you're going to go look at various different components. Excuse me. But this is a pretty simple one. And the idea for this is we want to do this in phases. We don't want to do the entire thing like with some giant monolithic project where we do everything all at once. What we want to go do is we want to go establish what are we doing, right? That's the baseline. So ping might make sense. Maybe we could do, a serial or a wget, to some, website. And then we go through other service level objectives. One of the big ones is what is our requirement for things like uptime, right? So for me on the boat, I'm not doing this very often. I don't have, people using the network on my boat 24 hours a day. This is on the weekends. Sometimes people will come over, we'll hang out. And while we're, at shore, close to shore, people want to be able to go use the internet, right? Or I'm there and I want to go use the internet. So, we want this to be available. Let me put this back over here. We want this to be available when people are using it to a reasonable degree. So, we don't need this to be 100% uptime. And that's a good thing because nothing has 100% uptime. Right? Doesn't exist. You can get very, 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 very close to it, but you can never get to 100. So what we want to do is we want to define what's reasonable. So, let's just say 95% of the time. Right? So we can go back to these indicators that we have over here, and we can just keep that somewhere, right? Keep that information and be able to go determine if we're meeting our service level objectives. So let's just start with that. We'll basically start with those as our requirements. So what you should do at this point is you should go back and do a similar thing. What are your requirements? And your requirements might be more stringent than mine. If you're using this as your home router and you work at home, well, it would not be unreasonable for you to have a very high level of uptime requirements. And if we're doing this with one server, that may not work, right? Because one server at some point is going to go down. So what's the plan there, right? It might be a HA cluster, right? So what we want to do is basically take this, down the line, figure out how we're going to go do this. Now, you do need to take into account your ISP. Your ISP is going to have their own availability, right? So there's going to be restrictions there. So it doesn't make sense to over-engineer this to a degree where we're going to be 99.59's worth of uptime, whereas your ISP is only on the hook for 98% uptime, right? So what we want to do is we want to match that. Or if you want to go further, maybe what you do is you have your Ethernet connection upstream to your cable modem be your primary connection, and then you have a USB cell modem that you plug in, and you have that be a secondary path. But what it is basically you state your business requirements, figure out what those are, right? Then translate those into technical requirements. So the next thing that we're going to go do, and I could probably put this into a different video, but I think I'll sort of touch on it here, and we'll start the conversation here, and then you guys can start looking through some of this stuff. And then what we'll do is we'll come back and we'll sort of make this a little bit more formal. So the next thing I want to go show is a couple different documents, and I'll put these in the description of the video. So, so I've got a couple different sort of documents. So the first one here or these are just entries in Wikipedia, and I picked Wikipedia just because it's a nice central place. It's not tied to any particular design methodology or whatever. It's just sort of pretty straightforward. So we're looking at systems design. So that's basically what we're doing at this point. Is we're looking at systems engineering. We're going to be engineering a system for our use. The maintenance and manage of that would fall under something like systems administration, potentially. Depends on how you go do it. So we're going to go look at that. So we can go look at some of this and sort of look through the kind of different pieces of our design. So, what is the system architecture? What is the logical design in terms of, an abstract representation of how the data flows? So these are good things to sort of put together in visual diagrams, right? So, if we go back and we look over here to my diagramming application, and we go, let's say, move this up a little bit. Something like internet switch clients Wi-Fi, the client's connected. Not a great diagram, but you get the idea. And then this is going to be our router that we're looking at. So this might be the flow, right? So the clients can get to the internet through our router. Right? And then what we're probably going to go do is we're going to go zoom in to our router, and then we're going to go ahead and look at things like we're going to have ETH0, right, or whatever your version of Linux is calling ENSP 0, whatever it is. And you're going to go ahead and have WLAN 0, right? And then we're going to go ahead and have additional configuration stuff, right? So this might be ETH1 over here, right, which is USB SALT modem, and that's going to be your internet. So that's the first piece, and then we could go break down the various different services that we're running, right? So we might be IP tables, right? And that could be all the rest of the stuff that we're doing to provide the additional services on our thing. I'm not going to go diagram it right now because I want you to think about this stuff yourself. IP tables, I think, is pretty straightforward because we're going to need to go do some kind of natting if we're to be doing this on Linux. And IP tables is basically the mechanism that you might want to go use for that. Now you could be using Firewall D completely fine. Firewall D is just a front end to IP tables, which is in turn a front end to NetFilter, which is everybody reinvent the wheel. Anyway, so the next thing we have is we have a software requirement spec. So this is a good sort of format for sort of a document that you're going to go put together. Now this is specifically for software engineering, but one of the things that you will see is that one of the big changes that we've had as an industry, and we won't be able to completely do it here, or at least I think it's probably not worth the effort to do it here for something like a small router. But one of the big changes that we've seen as an industry is the move to managing your infrastructure as code, right? So when we're looking at managing things as code, we're looking at software. So software engineering is a useful thing to go do. So we might actually go look at putting together something like an actual software requirement specification. So, and I think a lot of this is actually very useful to do. So when we go look at this, some of this we can skip over, but I think one thing that you might do is basically just take this whole thing, throw that into a document, and use this as a basic outline for putting things together. Now, some of this we won't have. We probably won't have a local database requirement. You might, but in this case, we probably won't. So we can go skip that. We can go look at our performance requirements. We can go look at our functional requirements, right? And the nice thing about this is you go, however, they're looking at in software engineering, functional requirements defines a function of a system or a component. Like, what is it doing? What are the functions that it, is going to provide? Well, hey, we already have some service level indicators for that. So you could go plug those in there. External interface requirements. Well, we're going to need to have something to connect to the internet. What is that? Right? We're going to need to go ahead and have a Wi-Fi device. And so what we want to go do is we want to go define these things. We want to go look at the actual, potential device itself. Like, what are the system interfaces that we're using? Again, this is not stuff that we don't already have, but this is going to be a formal way of presenting it, right? So that's the first piece. And you can go look at other kind of pieces if you want to go into, a more formal functional specification that you could dig into for, the functional section, right? So you could actually go break that out. Product requirements doc. This is a good thing to sort of go over in terms of like gathering requirements. And then an initial thing that I'd like to have you guys take a look at, and again, we're not going to be able to go implement this, is something called 12-factor design. 12-factor design is, again, very much related to software development, but it's also related to the idea of DevOps, right? So, and I know a lot of you guys are interested in sort of going down a DevOps path in your career. This is something that you will see come up quite often. Now, again, a firewall is not necessarily the use case that maybe people, or not a firewall, but a routing proxy, natting firewall kind of thing, whatever you want to call it. That's not something that everybody would, think of when it comes to DevOps, but it actually is something we could go use at least some of this for, right? So, code base. One code base, tracked and revision control, many deploys. So right off the bat, when we're putting this thing together, let's go put everything into a Git repository, right? Or CVS if you're old school, or RCS if you're even much more old school, or whatever you want to go use. Probably Git though. So put this into source control. So what we can go do is we can have a source repository where instead of having all of our configurations that we just go edit directly on the system itself, we make the changes and then we copy those files into Git, we update them, and we track our changes, right? So that when we decide that we want to go and implement this, we can deploy this very straightforwardly. Dependencies, right? We're probably going to have a bunch of dependencies that are going to be required to be installed on our version of, let's say, Debian that we're running, right? So if we're doing this from, Raspberry Pi 4, I'm going to, have probably a Raspbian OS. Could be Ubuntu, right? But it's Raspbian is the default supported distribution for that device. That makes sense to probably use that. If you're doing something like FreeBSD on a physical Intel based server that you're going to go use, well, great. Like you have more flexibility. Use FreeBSD. But we're going to have various different packages that we need to have installed, right? So those are going to be something that we should list out and preferably have integrated into our solution so that they pull those in, right? So that our dependencies are either delivered with it or we have some mechanism to make sure that those are installed, right? Configs. Keep our configuration in our environment, right? So, one of the things that you would see oftentimes, and I know that I had to deal with this previously, is you'd be supporting a web app and that web app would not have things like the Apache configuration as part of its install, right? So those were completely separate. You had the ops team managing the Apache configuration, and then you had the dev team managing the PHP code base, right? And it would make a lot more sense if we have a standardized Apache configuration file. Well, why we keep that separate? Let's just go put that as part of the project and we'll have that be installed, right? So what are the backing services that we're going to go use? This is one that's a little bit odd to people when they first come across it. But the idea is don't have dependencies that have to be local, right? So for example, we're going to be using, let's say, a proxy, right? So we can have a proxy running on the local system. When we're going to go configure something like IP tables potentially to go forward to that, right? Let's go ahead and have that be something that we set up in a way that it could be running local, or we could go forward to another, host if we wanted to go externalize that, right? Because that might be something that we do. Okay, cool. So, think about things like that. build, run, and release, right? So we want to go separate the build and run stages, right? So we don't want to go ahead and build this and then run at the same time. We want to build it so that we can go see if there are going to be any errors or issues, and then we want to have the ability to go ahead and run it, right? Processes, execute the app as one or more stateless processes. So I don't really think that we're going to need to worry too much about state too much in our firewall. State generally is going to be, things like session information that will need to persist. Basically, if you have multiple things that are running in like a pipeline, they get like a series of events. The you know the first step passes on information to the second one, so the second one needs to know what the state was from the first kind of thing. For us, it's a firewall. Things like sessions and stuff, we'll have that on our firewall, but if the firewall goes down, it's not really that big of a deal. If you want to be really advanced, there are ways to handle that. So you could potentially externalize where we're keeping track of our sessions and stuff, and then have that be in like a shared volume that we have between two of our our servers. So we get an HA failover kind of thing. I'm not going to get into that, but feel free to do this. And then we want to go look at things like concurrency, so you can go scale out. That probably won't really apply to us, but it's something to kind of keep in the back of your mind. Fast startup and shutdown, so you can go, the idea would be that you can go spin up an instance and shut down an instance, and it won't be something like that. Again, probably for us is not going to be a huge thing. We're basically just going to be booting the OS, and then hopefully everything should just be running. And then dev and production parity, right? So this goes back to kind of our code base and sort of a dependency tracking and our configs all being kept in. The idea is that we should be able to deploy this on a development or a staging environment, very, very easily. And probably the best way to do that is just to blow away the VM and recreate it every single time you deploy this, right? So that you don't, you're not sort of leaving any legacy stuff there, right? So you're sort of guaranteeing that it's a clean environment. You install everything, it's there from scratch. And we do the same thing in the next one. And then logs, treated logs as event streams. I think basically what we'll do is we'll send everything to syslog, which is the native way that most of these things are going to be acting, as opposed to having sort of applications create log files. So we sort of get that for free, being that we're on a Unix system and we're using syslog, and then we could go send those logs to an external log server very easily if we wanted to. And then admin processes, it shouldn't be something that we need to go do all the time. So they should be sort of one-off events. And you can dig into any of these, sort of as a kind of thing, right? So you can kind of go and look at these and sort of get more detail. So this is a 12 factor, the number 12 factor factor.net. You can go look at that. And again, I'll put all the links to these in the description. So your assignment for this week basically is to figure out what your requirements are, figure out what the technical sort of requirements are going to map to. And then I think probably in addition to that is go through, some of these documents that I'm gonna go include there. Maybe create your initial spec, your initial sort of design document. Doesn't have to be filled out, but you go create that with a template and then sort of fill out the pieces that you can. And then start doing some research into how you want to go implement this. So, one of the biggest things is don't recreate the wheel. If other people have successfully built Linux-based Natting firewalls before, well, let's go look at what they did. No need to go rebuild this from scratch if we don't have to. So let's start looking at that. And I will note, just sort of as an aside, traditionally, if this was a real life workplace kind of project that we were doing, there's an additional consideration that we should make before we get into sort of any of this design stuff, which is there's sort of three ways to implement a project like this, right? You could build it, you can buy it, you can modify it, right? So those are basically the three. And what we want to do is we want to go look at what are the pros and cons of buying it, building it, and just modifying an existing thing, and go from there, right? You could do that in this case as well if you wanted to. And I think probably buy it is out of the equation, because that's not going to give you anything to go put on your resume. It's not going to give you anything that you can go put into Git. It's not going to be something that you can document and sort of have as a project that you can go show during an interview to an employer. So buy it's out of the window. But there are plenty of projects that you could implement, right, that are available. If you do a search for open source firewall project, you're going to find a bunch of them. And some of them are pretty damn good. pfSense comes to mind. That's a really, really nice one. And, for you, it might make more sense to use an existing thing as opposed to building it yourself. That's fine. But the idea is that's something that in a real life situation, when you're sort of thinking about this in a workplace, that you'd want to go consider. So there's two additional considerations that you're going to want to do. We don't necessarily need to do. Well, I'll put them on there as well. You're going to need to go ahead and have some constraints. So in real life, you are going to have a deadline for when this needs to be due, right? And there's probably going to be multiple deadlines. So when does the design need to be finished? When do we need the actual product? And that's the biggest piece, is that when does the actual deliverable need to be done? So figure out some dates for this. Now realize that I'm going to go spread this out across a number of weeks while we put this project together. But, let's say, to give you way more time than you would probably need, let's say 2 months, right? So you are on the hook to have this done in 2 months. And part of what you're going to need to do is you're going to need to figure out, how do you want to go spend that time, right? So that's going to be part of one of the pieces of this, is we're going to need to put together some kind of project plan to be able to go ahead and implement this. So that's one piece. And then the other piece is, what's your budget, right? So that's an important piece to know. And that's one of the big reasons why a lot of times people will build things, right? So when you're looking at how much money does it cost versus, when you buy it versus creating it, those are things that you need to take into account. In real life, you'd probably want to account for your time as well. So you want to figure out, what is your hourly rate? What are you worth an hour? And if you're going to be dedicated to this for, 50 hours, how much does that compare to buying, a Juniper router, or, a Cisco router, or whatever it is, right? What does that work out to be? Because one of them may be much more expensive. And a lot of times it's actually the building it yourself may be much more expensive. But in this case, we're looking at learning, right? That's primary objective of this, is not just to build this. I could go buy a hotspot. It would fulfill the requirements pretty fine. In fact, I have a hotspot, but we're gonna do this, for fun. And you can go build this out. So yeah, takeaways. By next week, we want to have a rough spec that goes over what your requirements are in terms of what it does generally, and then the technical requirements that it maps to. You're going to want to have that spec filled out to the best of your ability for the things that you know. You're going to want to do some research into the technologies that you're going to go ahead and use, and you can have an idea of the budget in terms of monetary, that you can go spend, and time, right? So have that for next week, and have fun. Don't stress yourself out. You can't screw this up. This isn't for anybody else. This is just for you. So play around with it. Feel free to change what you're doing midstream. You don't have to, do my project. In fact, for most things, Raspberry Pi is not a good platform for a router. So it's actually probably would be much better to use an old laptop, or, a cheapo, Intel NUC, maybe something like that would be fine. There's a bunch of other ways to go do it. But this is something you can play around with yourself and figure out. So have fun with it, enjoy, and looking forward to see what you guys come up with.